Okay, now I'd like to show you a couple more things about box and whisker plots and how they can be used to compare two data sets. So here we got set 1 and set 2, and I've ranked them in order. And we've got measurements which don't have units in this case because it's just an example, but they probably would in real life. So let's look at set 1 first of all. So n is 15. And I've calculated the mean, and that is 8.2, so that's adding up all these measurements, dividing it by 15. Okay, now let's have a look at the median. So that is the middle value, so that in this case it would have 7 values smaller, 7 values larger. So that's this here. So median, excuse me, median is 5. So here our mean and our median are not so similar as they were before. So that's the 8th value in the set, and now I'm going to divide into quartiles. So that's the same as before. So that would be the first 4 values. Second set of 4 values, I'm counting the median twice because n is an odd number. So here are 4 quartiles. So the interquartile boundaries is 4 to 6, and the range of the whole sample is 2 to 35. So I'm going to draw that with a little arrow, I think, and so that's 33. So 35 minus 2 is 33. Okay, now let's do the same for this data set, for set 2. So here n is 16, so that's an even number. I've done that for a reason, and I've calculated the mean of this sample is 19.3. And the median, so here we have to go slightly different. So here we have to take the, let's see, so we need 7 values smaller. Yeah, so you take the 8th and the 9th values, and then take the average of them. So that means that is 21.5. Okay, so that's the average of 21 and 22. And now we can do the interquartile. So that's slightly simpler this time. We don't have to take the median twice because the median isn't actually in our data set. So here we just take the first 4, second 4. Here are 4 quartiles, and our interquartile boundary we're going to use for our box and whisker plot goes from 13 to 27, and the range is the same as before, so that's 2 to 35 or 33. Okay, so now we're going to compare these two data sets on a plot. So let's have our axes first of all. So here we're going to make 2 different columns for the 2 different data sets, and so here we need our scale. So 10, 20, 30, 40. So we're doing it the other way up than we did before, but that's okay. Okay, so first thing I'm going to do is for set 1, let's add the median first of all. So that's 5. That's down here. Something like that. Let's have the boundaries, which are 4 and 6. This is quite a small, so there's my box. I'm using those to draw my box, and then the edges of the range are 2, about here, and 35, which is all the way up here. Excuse me, my wonky line, but you get the idea. So we have a very, I can do that again. Okay, so we've got a very large distribution of values above the mean, but everything's quite close together below the mean. Okay, and now let's use that, do the same thing for set 2. So here, our median, let's put that on first, is 21.5. But here, interquartile boundaries 13 and 27, something like that. So there's our box. You'll be doing this slower on nice graph paper, so it'll be easier for you. And then again, boundaries of the range are the same, so 2 and 35. So there you go. Oh, so those are the so I've realised I've made a bit of a mistake here, and that is I shouldn't have drawn this massive line here. So this is an outlier of my sample. I'm going to explain that in a minute. So what we need to do is find the size of our interquartile boundary box. So in this case that is 2. So outliers are points more than 1.5 times the interquartile boundary away from the boundary. There's probably a snappier way of explaining it, but so in this case our range of the interquartile boundary is 2, so there we have to look 1, 2, 3 away, because 3 is 1.5 times 2. So there we have to go from 6 to 9. And then anything outside that we have to mark separately. So here the 15, 21, 35 we have to mark separately. So this is, the whisker is 3, which is 2 times 1.5, and the 2 comes from here. And here the interquartile boundary is the size, the range of that is 14, so times 1.5 is 21, so 27 plus 21 would be 49. Okay, so here 4 minus 3 is 1, we don't have anything smaller than 1, and 13 minus 21 is minus 8, and we don't have anything like that. Okay, so these are the ones we have to mark as outliers. So that's these guys.